Hello and welcome to Diksha Karnataka YouTube channel, and in the COMEDK 2026 series today I am going to discuss top 15 PYQs from the chapters moving charges and magnetism and matter. Out of it, obviously moving charges and magnetism is one of the most important chapter. Magnetism and matter questions are very easy, so let us start. I don't want to waste too much time, so let's start with the first question. A conducting wire bent into in the form of a parabola of y square is equal to 2x carries a current I equals to 2 ampere as shown in the figure. This wire is placed in a uniform magnetic field B is equal to minus 4k Tesla. The magnetic force on the wire is, so here if you see that here we have a wire which is not a straight wire. Now we know that if there is a straight wire carrying current, if there is a wire of straight wire carrying current, okay, the force acting on it is given by BIL sine theta. Okay, now here obviously or in terms of vector it can be written as force is a vector quantity, so in terms of force it can be written as I into L cross B. Okay, I into L cross B, that is the formula for force acting. Now magnetic field is given, you have to find the L vector. Okay, so how to find the L vector? Obviously if you see in this diagram particularly, the current is being carried from A to B like this, so the L vector must be in this direction. So this must be the direction of L vector from A to B. So what is this direction? This is positive y direction, so this must be negative y direction, so the vector must be minus j cap direction. Now you have to find the magnitude of L vector. How to find the magnitude of this vector? When the equation is given y square is equal to 2x, what you need to do, and if you see that in this diagram x coordinate is also given, okay, so let's put that over here. So y square equals to 2 into 2 for this point, for this line. Okay, so y equals to plus or minus 2. What is the meaning of that? That means here the point is plus 2, y equals to plus 2, and here y is equal to minus 2. So what is the distance between these 2 points? It will be 2 minus minus 2, that is 4. So the L vector is actually minus 4 j cap. Why minus 4? 2 minus minus 2, okay, 2 minus minus 2, so difference between the coordinate, that is 4, okay, and obviously it is along the negative y direction, so that's why it is minus. Okay, so minus 4 j cap is the L vector. Now you have to put the formula and calculate the force. So force is equals to I. Current I is a scalar quantity, current is a scalar quantity, so 2 into L vector is minus 4 j cap into B vector is minus 4 k cap, okay, minus minus plus, so we get 16, 4 4s are 16, 16 2s are 32, and j cap cross k cap. Now what is j cap cross k cap? Those who forgot the cross multiplication, you need to remember I cap, j cap and k cap. So I cross j is k and j cross k is I. So j cross k is basically I cap plus I cap. So 32 I cap. So if you are going in this clockwise direction, everything is positive. If you have to go in the anti-clockwise direction, then it will be negative, right? So it will be 32 I cap is the answer for this question. So correct answer option B. So as you can see, the question is not super difficult but neither super easy as well. If an electron is moving with the velocity v vector produces a magnetic field B, then the direction of field B will be same as the velocity v. So basically we are trying to find the direction, okay, all the options are same. So direction, we have to find the direction of magnetic field B. So electron is moving, it's not a positron, electron is moving in this direction. Suppose this is the electron. What will be the direction of magnetic field? Magnetic field lines will be in circular. and if this is the direction of electrons, then the magnetic field will be in this direction. Okay, it will be in this direction, which is perpendicular. So if this is the direction of V, magnetic field will be in this direction, which is perpendicular, tangential to any point. Okay, if you draw a circle, it will be tangential and it will be in this direction. The direction part, if required, I will explain, but direction only they are trying to find whether it will be in the direction of perpendicular or parallel. That's what they are trying to say. So its same direction is wrong, opposite direction is wrong, perpendicular direction is correct. So option C is correct answer. So basically velocity V and magnetic field B, they will always be perpendicular to each other. Now next question, the torque required to hold a small circular coil of 10 turns, area 1 millimeter square, carrying a current of 22 by 44 ampere in the middle of a long solenoid of 10 to the power of 3 turns per meter, carrying a current of 2.5 ampere with the axis perpendicular, etc., etc. So a lot of complicated stuff. Let us understand from the figure itself. Here we have a small coil, area is given, number of turns is given, the current is given. Okay, so what is the magnetic moment of a small coil? Magnetic moment of a small coil is given by NIA, National Investigative Agency. Okay, so that means it will be number of turns is 10, current is 21 by 44, and area is, I think, 2 millimeter square, 1 millimeter square. So 1 millimeter square means 1 into 10 to the power of minus 6. 1 millimeter equals to 10 to the power of minus 3 meter. That means 1 millimeter square is equals to 10 to the power of minus 6 meter square, right? So that's what we are doing here. So magnetic moment we have calculated. Now inside a solenoid, will have a magnetic field developed. Okay, so what is that developed magnetic field? The developed magnetic field inside the solenoid is given by mu naught capital N I. Okay, mu n I. Now here I have mentioned capital N to differentiate it from the small n. That's it. Okay, now here obviously mu naught is 4 pi into 10 to the power of minus 7. Number of turns in this case is given as 10 to the power of 3 turns per meter, and current is 2.5. So 10 to the power of 3 into 2.5. Okay, now you can simplify it, but obviously as you can see in this question, the magnetic field and the area vector of the plane, they are perpendicular to each other. That means the angle is 90 degrees. So the torque acting between them will be mb sine theta, mb sine 90, which is sine 90 is 1. So simply mb. M is calculated, B is calculated, just put the values. M is 10 into let me simplify that. 10 into 10 to the power of minus 6 is 10 to the power of minus 5. Okay, so 21 by 44 into 10 to the power of minus 5 into 4 into pi is 22 by 7. Pi is 22 by 7, and we have 2.5. And what is the 10 to the power situation over here? 10 to the power of minus 7, 10 to the power of 3, so 10 to the power of minus 4. It will be 10 to the power of minus 4. Okay, so now simplify. 22 by 2, 7, 3, 2 to the 4. Okay, so now let's simplify. So you get this as 10 to the power of minus 5, 10 to the power of minus 4, so 10 to the power of minus 9. Now if you multiply 3 to the 6, 6 into 2.5 will be 15. Okay, so it will be 15 into 10 to the power of minus 9. Now if you see the option, it will be 1.5 into 10 to the power of 8. Obviously this much is clear. So if you take one decimal in, it will be 10 to the power of minus 8. So correct answer for this question is 1.5 into 10 to the power of 8, right? Newton meter. Now let's move on again. Easy question, but requires some steps involved. Okay, it's a computer based exam, so definitely you can take a little extra time. A horizontal overhead power line carries a current of 90 ampere east to west direction. So overhead line is carrying some current. Okay, now overhead line means it will basically a single line. Okay, it is carrying from east to west. Okay, east to west direction it is carrying a current. Okay, so this direction is up, this is down. Now how to show north and south direction? So north will be in this direction and south will be in this direction. Obviously it's a three-dimensional figure, so you cannot always draw north, south, east, west, because here up and down is also involved. Okay, so this is the current carrying wire, and it says that what is the magnitude and direction of the magnetic field due to the current 1.5 meter below the line. So below the line 1.5 meter, what is the direction, magnitude and direction of the magnetic field? So if you see that, now if you read the option carefully, this question is not about magnitude. Magnitude is calculated and all the magnitudes are same. You can calculate the magnitude, but the question is not asking you about magnitude. Basically it's a direction question. Just to give you a little bit more extra work, if you don't read the option, you will start calculating the magnitude, you will make mistake, your answer will not match, then you will think twice. So just to confuse you. So if you read the options carefully, you will realize it is not about magnitude, it's only about the direction. So this is the direction of current. What is how to find the direction of magnetic field? Point your thumb in the direction of current, then the fingers, your curled fingers gives the direction of magnetic field. So here the current is in this direction, so below here, okay, the magnetic field will be in this direction. Magnetic field will be out of the paper. That means what is the direction of magnetic field? It must be in the direction of south. So magnetic field will be in the direction of south, so it will be south is correct answer. It is not about the value, it is about the direction only. So in such cases you don't need to calculate the values unnecessarily if it is not asked. Two wires of current 2 ampere and 1 ampere are enclosed in a circular loop. Another wire of current 3 ampere is situated outside the loop as shown. The B dot dl around the loop is. So we know that B dot dl is actually equals to mu naught current enclosed. So anything which is outside does not come into the picture. Whatever is only inside this loop, that is only included. So 2 up, 1 down. So what is the net current? Net current is 2 minus 1, that is 1 ampere. Okay, so what is the mu naught? What is the value here? It will be simply mu naught. Okay, so B dot dl is simply mu naught. Okay, easy question. This question is easy. Now if you want to study with us for a 30-day crash course for your COMEDK preparation, definitely you should consider COMEDK 30, which will start from 6th of April. The classes will start from 6th of April. It's a comprehensive crash course for your COMEDK preparation. Here you will get complete syllabus coverage of 11th and 12th. You will also get 5 full-length mock tests including physics, chemistry, maths, each paper. You will get daily live doubt solving sessions. You will get lecture notes, DPP practice for practice, etc., and also PYQs of last 10 years solved, right? So everything included in this crash course, and the price for the entire crash course is only 2499. So I hope that you will, if you are interested in scoring well in COMEDK, we have proven track record for COMEDK, and if you really are interested in scoring well in COMEDK, definitely you should register for this crash course today. Don't wait too much before it's too late. Right now let's continue. Now next question, a very long conductor carries a current of 1 ampere. The magnetic field at a point whose distance is 0.1 meter from one end of the conductor is. So here we have a very long conductor, but the conductor is first of all not infinite, and we are trying to find magnetic field at a point where it is at a 0.1 meter from the wire at the end, not anywhere else. We are trying to find it at the end of the conductor. Now how to solve this kind of questions? So in this case, what you have to do, you have to consider that suppose the length of the wire is L, you consider the wire is extended on that side to the length L as well. So the overall length of the wire is very long, okay, and you can apply the very easy formula. Magnetic field due to a infinitely straight current carrying wire is given by mu naught by 2 pi I upon R. Right, this formula we'll be using, but that is for entire length of the wire, double length of the wire. So here our own magnetic field will be actually half of this total magnetic field. Okay, our own magnetic field, which is only because of this, will be half of the total length. So what we have done, we had only half of the wire on this side. We increase the length. We imagine that the length is complete. Okay, this is a very unique technique that can be applied to straight current carrying wire. It can be applied if they ask you magnetic field at the end of a solenoid. Again, you have to consider the solenoid is complete, because obviously you cannot apply this formula if at the end. It is only applicable where the both sides are far away. Okay, so in that case you have to use this technique, and otherwise you can use integration technique, which is fine, but here it will be easier technique. Just calculate the magnetic field, divide it by 2, and you will solve it. So here you will get, it will be mu naught by 4 pi I upon R. This is not a general formula, this is a very special formula for this case only. So mu naught by 4 pi is 10 to the power of minus 7. Current given here is 1 ampere and the distance is given 0.1 meter. So that will be 10 into 10 to the power of minus 7. 1 by 10, 0.1 is 10. Okay, so 10 into 10 to the power of minus 7 or 10 to the power of minus 6 Tesla. So answer is 10 to the power of minus 6 Tesla. Option C is correct. Now let's move on. A voltmeter which can measure 2 volt is constructed by using a galvanometer of resistance 12 ohm, and that produces maximum deflection for the current of 2 milliampere. Then the resistance R is, so here we have a galvanometer. The resistance of the galvanometer given here is 12, okay, and we do not know this R. The maximum galvanometer current given here is 2 milliampere. That means at 2 milliampere the voltage across this should be equals to 2 volt. Okay, now what formula we will be using? Very simple, Ohm's law. V equals to I into R plus G. Okay, V is equal to IR. Now here R is not alone, there is a galvanometer also there. So V is equal to I into R plus G. So now R plus G, this is also a galvanometer formula. V is 2 volt, current is 2 milliampere, so that is minus 3, that is 10 to the power of 3, that is 1000. Okay, so resistance equals to 1000 minus 12, G equals to 12 ohm, so it will be 988 ohm. Okay, so correct answer is 988 ohm, option B. Easy question. Don't waste time on easy questions. Try to solve it as quickly as possible. A straight wire of length 2 meter carries a current of 10 ampere. If this wire is placed in a uniform magnetic field of 0.15 Tesla, making an angle 45 degree with the magnetic field, the applied force on the wire will be. So force acting on a current carrying wire, I just said in the first question also, it is BIL sin theta. BIL sin theta, L cross B. Okay, IL cross B. Okay, so that cross goes away when the angle is given. So B is 0.15. Current here is 10 ampere. Length of the wire is 2 meter. angle is 45, so sine 45 is 1 by root 2. Very simple, do not waste too much time. So 0.15 into 10 is 1.5, and into 2 divided by root 2, so it will be 3 by root 2. So correct answer is 3 by root 2. Not always you require a calculator, even though calculator is allowed in the COMEDK. You should not, you try to avoid it as much as possible, especially if the answers have root 2, pi, etc. in the answer. For example, here also we will not be using calculators. A circular coil of 100 turn and effective diameter 20 centimeter carries a current 0.5 ampere. It is to be turned into a magnetic field of B is equal to 2 Tesla from position of theta equals to 0 to theta equals 180 degree. The work required in this process. Very interesting question, nothing difficult. First you have to calculate the magnetic moment of the circular loop. So what is the magnetic moment? Again, National Investigative Agency. So number of turns is 100, current carrying is 0.5, and area is pi r square. Okay, area is pi r square. So it will be 0.5 into 100 is 50 into pi, and r square is 20 centimeter. So 20 into 10 to the power of minus 2 whole square, that will be 50 into pi into 4 into 10 to the power of minus 2. Okay, if you just calculate it properly, you will get this. So 1 0 is reduced from this 0, and then square of that, it will be 10 to the power of minus 2. If you are confused, you can write 400 into 10 to the power of minus 4. That is also okay. Now 4 into 50 is 200, pi into 10 to the power of minus 2, or 10 to the power of minus 2, 2 zeros cancel, so you get 2 pi. So 2 pi is the magnetic moment of the coil. Now, so here we have a magnetic moment. Magnetic field B is given. So what is the potential energy when the angle is 0? The potential energy at the angle is 0 is given by minus mb. Okay, mb cos theta. Okay, potential energy's formula is minus mb cos theta. So for theta equals to 0, cos theta is 1, so u is equal to minus mb. So put the value, minus 2 pi into b is 2 Tesla, that is minus 4 pi. This is initial potential energy. Final potential energy, when you rotate by an angle equals to 180 degrees, the potential energy final is given by minus mb into minus 1. Okay, cos theta is minus 1 for 180 degrees, that is mb, that is plus 4 pi. So what is the work done? Work done is final potential energy minus initial potential energy, that is 4 pi minus minus 4 pi, that is 8 pi. So 8 pi is the work done to rotate it by an angle of 0 to 180 degrees. Now let's move on to the next question. A current carrying loop is placed in a uniform magnetic field in 4 different orientations as shown in the figure. Arrange them in the decreasing order of potential energy. Again, potential energy based question. Potential energy, torque, etc. Even Ampere circuital law, force acting on a wire. These are all very common in COMEDK. So what is the potential energy formula? Potential energy formula is minus mb cos theta. So smaller the theta, okay, smaller is potential energy. Potential energy is not minimum for 90 degrees because 90 degrees will give you 0. 0 degree the angle is even smaller, so that means it will be negative. Negative is smaller than 0. Understand that. So here what are all the angles? First of all, let us write down the angles. So the angle here is 180 degrees. Okay, angle here is 90 degrees. This is an obtuse angle. Okay, obtuse angle, I am assuming this could be 120 degrees. Okay, assuming, obviously not exactly. Here it is an acute angle, so assuming this may be 60 degrees. Okay, this may be 60 degrees. Now as I mentioned, smaller the angle, smaller the potential energy. So this will be the smallest, this will be the smallest, and this will be the largest. These two will be in between. Okay, now this is bigger angle than 90 degrees, so this will come second, this will be second, and this will be third. So the order is decreasing order. Decreasing order means highest first. So first 1, 2, 3, 4. Okay, so the order will be 1, 3, 2, 4. 1, 3, 2, 4. 1, 3, 2, 4. Just a second. I think there is a mistake in the option. So arrange them in decreasing order means it should decrease. Okay, it should decrease. So there is a printing mistake. I think this will be 1, 3, 2, 4. Okay, it will be 1, 3, 2, 4. So this is the only correct option that is possible. Okay, do not reverse the order 1, 3, 2, 4. This can be the answer if it is increasing order. So smallest first, slowly if you are increasing, that is called increasing order. Okay, decreasing order is mentioned in the question. That means it will be 1, 2, 3, 4. 1, 3, 2, 4. 1, 3, 2, 4 should be the answer for this question. Now let's move on. Needles N1, N2 and N3 are made of a ferromagnetic, a paramagnetic and a diamagnetic substances. A magnet which brought close to them will attract N1 and N2 strongly but repel N3, attract N1 strongly, N2 weakly and repel N3 weakly, attract N1 strongly but repel N2 and N3 weakly, attract all three of them. So obviously for paramagnet it will be weakly attracted, for ferromagnet it will be strongly attracted. So attract N1 strongly, N2 weakly and repel N3 weakly. Diamagnetic substances will be repelled weakly. So obviously this is the only correct answer for this question. Now let's move on. The given figure represents a material which is, so here as you can see the magnetic field lines are repelled weakly, so that means it's a diamagnetic substance. So correct answer is diamagnetic. 2024 question, easy question, right? As I mentioned, from magnetism and matter chapter questions are easy. If a paramagnetic substance is placed in a non-uniform magnetic field, then it will move from, paramagnetic substance moves from weak magnetic field to stronger magnetic field. So weaker to stronger magnetic field. If it is a diamagnetic substance, it will move from stronger to weaker magnetic field because it's repelled, right? Now next, which of the following properties is false for a bar magnet? It does not produce magnetic field. Bar magnet does produce magnetic field. Its poles cannot be separated. It cannot be separated. This is a correct statement. The points in north-south direction, this is a correct statement. It like poles repel, unlike poles attract. So this is also correct statement. So only wrong statement is it does not produce magnetic field. So this is a wrong statement. Now next part, last question of the day. Following figures show the arrangement of bar magnets in different configurations. Each magnet has magnetic dipole moment M. Which configuration has highest net magnetic moment? So how to find net magnetic moment? First of all, what is magnetic moment for two magnets? Magnetic moment is from south pole to north pole. Okay, so this is the magnetic moment, and when you add two vectors, they are all vector quantity. Magnetic moment is a vector quantity like dipole moment. So if you want to add them, you have to add them vectorially. Okay, you have to add them vectorially. Now in this case, it is in this direction, this is in this direction, they will cancel each other, so net magnetic moment will be 0. Okay, now what about angle 30 degree? If you try to calculate, smaller the angle, larger is the resultant of the two vectors. Smaller the angle, larger is the resultant of two vectors. This is valid for vectors as well. Remember that. Smaller the angle, larger is the values. 0 degree angle means largest value. They just gets added, right? So smaller the angle, larger is the value. So correct answer will be option 3. Okay, here also they are in the same direction. So that means angle is actually 30 degree. Here the angle is 60 degrees. 60 degree is bigger than 30 degree. So largest possible value of magnetic moment will be in case of 3, that is option C. So option C is correct. Remember this very simple fact, smaller the angle, larger is the resultant of two vectors. Okay, so this is the end of today's lecture, and if you want to purchase COMEDK 30 crash course or COMEDK 30 rank booster test series, link of that is given in the description. Rank booster test series is a test series consisting of 12 full length paper, all subjects included, and this is only available for 999, which is almost of the price of nothing. So if you really want to test yourself, if you are prepared with the theory but you want to practice the questions, definitely you should go for rank booster test series. Okay, we will be back with more chapters very soon. Till then, bye.